All right. Up next, we have Manu, and Manu is an interesting person because he's been a consultant on his own since 2006, right? So here's another person of a different caliber, not running through any employment or company, but running as an individual consultant. And he is here to present a very entertaining talk. The title itself ensures that it's going to have humor in it. So I've already set the stage for you, Manu. Over to you.
Thank you, Gautam. Hello, everyone. Welcome to my talk, Look Ma, No Sidekiq, a peek into the async future. My name is Manu. I'm a full-stack developer and a Rails consultant. If you want to connect with me, you can email me or hit me up on Twitter. So let's jump in. The conventional Rails wisdom is that any expensive operation must be done in a background job. We have seen several speakers talk about this. And expensive here means time-consuming. It could be either due to CPU or due to blocking I/O. Some examples of blocking I/O will be calls to external APIs or slow DB requests. But why? What happens exactly if we don't use background jobs? Let's find out. Here's a load test of a typical Rails controller endpoint. For this test, the Puma is configured with 1 worker and 5 threads. We are sending a constant traffic of 10 requests per second. And everything looks fine. Each request is returning in about 200 to 300 milliseconds. On the left are values from the Rails log, and on the right are values from the load test app itself. Both roughly match in this case. But what happens if we mix in some slow requests? A slow request, in this case, would be a controller endpoint which is making a call to an external API. We are just going to mix in 1 out of 5 requests to be a slow one. Looks pretty okay, right? As expected, the new controller endpoint has a slow response time, and the other requests are returning fast. Not really. If you see carefully, the right graph looks a bit cut off. Let's see the full graph. This is the actual latency graph with all the values plotted. Some of the requests are taking 10 to 18 seconds to run. Even though there is plenty of CPU available, the CPU is just at 55%, the app is not able to service all the requests in a timely manner. So what's happening here? We are using Puma. And Puma has a request per thread architecture, which means that for every request, it gets allotted to a separate thread. And we have started Puma with a fixed number of threads. When a thread is waiting for I/O, it is not available to service any other requests. All the threads get busy, waiting for I/O, leaving no free threads. If you see, there's a disparity between the numbers from the Rails log and the load test app. This is because the requests are spending a lot of time in Puma's queue, waiting for a thread to be available. This is not a metric that's captured in Rails log by default. If you have ever seen a Rails app with slow response time, but when you look at the log, it says fast rendering, this is what's happening. The requests do not have any threads to service them, so they just wait in a queue. And we cannot just increase the number of Puma threads because the overhead in context switching between threads can be considerable. To recap, slow requests tie up threads. That leads to high latency due to queuing. We can have timeouts. And we have inefficient utilization of resources like CPU. So, for a performant Rails app, we should not have any slow requests. And that means we should have Sidekiq or any other background job runner. So Sidekiq is absolutely necessary, right? Of course, it is. But not always, and not anymore. So what changed? The async gem by Samuel Williams. Magesh has covered this yesterday, but we will have a quick run-through of what the async gem can do. Here, we have some code which is making external API requests, which will take between 1 to 3 seconds each. Each request is made sequentially, so this will run in 6 seconds, 3 plus 1 plus 2. Now let's see how we can use async for this. We're just going to wrap each method in an async block. The method itself remains the same. And this completes in 3 seconds. What async has done is take these blocking I/O operations, which are run sequentially, and run them concurrently with no change in the underlying code. And I want to emphasize this. We did not have to change the underlying code. Just wrapping them in an async block was enough to have them run concurrently. And the first time I saw this, my mind was blown. If you're familiar with concurrency in JavaScript or Python, you have to mark a function as async, and you have to use await. Here, we did not change the function signature or how it is called. So how did async gem do that? It implements a fiber scheduler, and it has event-driven I/O. Fiber scheduler is introduced in Ruby 3.0, and it can convert blocking I/O operations into internally non-blocking operations. It's an incredible piece of engineering, and I urge every one of you to check out the async gem. I've just barely scratched the surface of what it can do, and the gem is just... So, how can we use it? During Magesh's talk yesterday, after it, I saw somebody asking the same question. Like, async is cool, fiber is cool, but what can we do with it, especially in our day-to-day work in Rails or Sinatra or any other web framework? For that, we need the Falcon web server, again by Samuel. And he has done a lot of work in this. He has written the async gem, the Falcon gem, and also contributed majorly to the Ruby fiber scheduler. It's a lot of work. So the Falcon web server is built on top of async. It has a request per fiber architecture. Every request gets mapped to a fiber. And there is no queuing. When a request comes in, it gets a fiber. That's it. And it's a drop-in replacement of Puma because it is rack compatible. Let's run the load test from the beginning of the talk again. This time with the app running on Falcon. Falcon is configured with one worker, and we don't configure the number of fibers because there's nothing to configure. And the traffic is 10 requests per second. We see that our regular endpoint performance is similar to that of Puma, maybe even a little bit better. What happens with slow requests? When we mix in the requests, we see that the fast requests remain fast. The slow requests have had no impact on the rest of the requests. That's just wow, right? Just by changing the web server, we have changed the performance characteristic of the app. Let's look at a common requirement. Fetch data from an external API and display it. In a regular Rails app, it is advisable to run this in a background job and then stream the data using Action Cable or Turbo Streams. We are going to do it a little differently. We are going to decompose the views. We're going to use Turbo Frames for that. How many of you have used Turbo Frames here? Okay, a good number. So /users is a route that we will navigate to. It returns a view which has a turbo frame, and the turbo frame SRC is set to /external/users. /external/users is a controller endpoint, as the name suggests, which is responsible for fetching the data from the external API. Let's see the code behind this. This is what /users returns. It's just a TurboFrame with skeleton HTML inside. A nice property of TurboFrame is that it will display the initial content inside the tag, which is then overwritten when the content is fetched from the SRC. The skeleton partial here shows a nice looking loading indicator. This is a /external/users controller. Very simple code to fetch some data and create some Ruby objects. And this is a corresponding view. Again, very standard Rails code to display @users using partial. We also wrap the entire view in a matching TurboFrame. Let's see it in action. First, /users get loaded, which shows a skeleton in TurboFrame, which gets replaced by /external/users content in about 3 seconds. TurboFrame will be doing most of the heavy lifting here. So let's see. We have the skeleton HTML with the loading indicators, which gets replaced by the content. And here is what the page looks like at the beginning. As you can see, there's a TurboFrame, and inside it are the loading indicators, which comes from the skeleton partial. And this is what it looks like after the content has loaded. The skeleton HTML has been replaced by the content. Very cool, right? TurboFrames is awesome. Now, let's run this app using Puma. Configured with 1 worker and 5 threads, we will load 8 requests simultaneously. 1, 2, 3, 4, 5, 6. What happened here? We have 5 threads. So the 5 requests finish in 3 seconds, and the 3 requests finish in 6 seconds. The last 3 requests had to wait for a free thread, and it had to wait for 3 seconds. And this is why we use Sidekiq. Now let's run this app using Falcon. 1, 2, 3. Since every request gets a separate fiber, all the requests were run concurrently. And thank you. All the requests finished simultaneously. This is amazing, right? Now we can make external API calls without fear. If the user is waiting for the results of an external API call, we can make the call directly. No Sidekiq required. This opens up a lot of possible applications which are impossible in Ruby or not very easy to do or efficient. We can have API proxies in Ruby. Or if your app is calling OpenAI, you can call it and stream the requests, stream the responses. So, Falcon is amazing, fibers are amazing, async is amazing. But it's not a silver bullet. This technique is useful only in case of blocking I/O. That's because fibers are cooperatively scheduled. CPU-intensive work can block the entire app. So what is cooperative scheduling? A fiber will run until it hits fiber.yield, as long as it wants. What the async gem does is it automatically calls yield for you when there is blocking I/O. But if fiber is running CPU-intensive tasks, it's your responsibility to call fiber.yield. Otherwise, it'll just continue running. This is in contrast to threads, where the Ruby VM will let a thread run only for 100 milliseconds until it says, stop, don't be greedy. Let the other threads run. And it will switch between threads. But a fiber will run as long as it wants until it hits fiber.yield. So if you have CPU-intensive tasks, then one fiber will run to completion and all other fibers will have to wait. This may not be something that you want in your app if you're running CPU-intensive calculations. So let's look at deployment of this. If you're unsure whether all your requests are mostly I/O, which it should be, you should be doing your expensive operations in Sidekiq. But say you're unsure. Your app is running fine in Puma, but you want to use Falcon. You can have separate instances of your app using both Falcon and Puma. Put a proxy in front, like Caddy or HA proxy, and then route the requests which are blocking I/O to the Falcon instance. So if you look at the demo app before, the /external is all the external API requests, and that can go to Falcon, and the rest of your requests can go to Puma. This is what I did for an app which was required to interact with a third-party API heavily, and it worked beautifully. So the subtitle of my talk was a peek into the async future, but I believe the future is now. Why? We have the async gem available. We have Falcon available. There are a lot of ways we can use this to build very powerful applications. That's all. Thank you. I'll be uploading the slides and the demo app to the GitHub repo later. You can check it out.
Thank you, Manu. We have time for questions, and I think there will be quite a few.
We have a question.
Hello, I am Navnath. So basically, we are utilizing async. Okay. So there are two requests. We said like they will be doing the parallelly. So if second request is depending on the first request, then how async works?
If the second request is depending upon the first request, is it necessary to run it sequentially?
So let's say second request requires the data from the first request.
There's no other way other than to run it sequentially, right? It requires the data.
Then it looks like async won't help me, correct?
It won't.
Okay.
Yep, just raise your hands high so our team can see. Hold on, there's a question here.
Hi, I'm Manu. I'm from Mindbody. So my question is like, so we know async programming. I mean, we use async programming in JavaScript a lot, right? How different it is, like the Ruby IO, I mean, like event-driven design from the JavaScript event-driven design.
It's very similar. So with fibers, it's very similar. With the async gem and fibers, it's very similar. If you don't use async gem, then it's very different. But the async gem kind of brings that kind of concurrency model into Ruby. Like even in JavaScript, what people say is don't block the event loop, right? Don't do CPU intensive tasks. Same here. Okay. If it's using blocking IO, you can go ahead and do it. But this is easier, as I said.
So in JavaScript, we have a separate run environment, right? When we actually do an async, it goes to a separate program which actually does the input-output calls handles. I mean, like there is a separate program, right? Which then pushes back to event memory, like from where the thread keeps polling.
The event loop of the JavaScript. Yeah. So the async gem implements the event loop also.
Okay.
So the concurrency models are very similar. How it works is also very similar, but how we use it is what is different. Like in JavaScript, you cannot miss synchronous and asynchronous methods. You have to write a method as asynchronous. Here you don't. You just like wrap it in async and it becomes asynchronous.
So is it necessary to use Falcon server to use async?
If you are going to use it in Rails, yes.
Okay, all right, thank you.
Yeah.
Okay. Hi, this is Prithvi. One important benefit of using Sidekiq is that you can retry stuff when it fails. Is there something you can do with async?
What is the benefit?
If something fails, you can retry it after some time.
No, I wouldn't recommend this technique if you for that kind of users, where there can be failure which you want to retry. This is most useful when your user is waiting for something and you want to show it immediately. But if you have like a background job, like sending email, that's perfect for Sidekiq. Even though you can do it, I wouldn't recommend it because no one is waiting for it, right? And it can fail. So let Sidekiq handle it, do the retries. But sometimes when you have an external API call and it fails, you want to show the user that it failed. Or maybe you want to retry it once and then show the failure. But the point is, the user is waiting for it. So you want to do it with the minimum amount of fuss possible. Like instead of going to Sidekiq and then back by a turbo stream, just call it directly.
Thank you.
Hi, my name is Risha. I'm undergraduate student. My question is, fiber, like we are creating fiber at a user level. But what if CPU finds, for CPU it's a one process, like it's a single process, but we are creating at a user level with different fibers. So what if CPU closes the fiber, which is thinks of a single process, but we are running 4 fibers or 8 tabs like you show it. And if we close that, if CPU closed at one single process, that all the fibers are closed. So is there any fix for it?
No, I mean, if the process dies, everything dies with it.
Yeah. But in threads, like if it, CPU knows there are different threads. So if one closes, there are still different threads are running.
So both threads and fibers are handled by the Ruby VM. It's not the CPU deciding whether to run. Like the context switching happens at the OS level for threads, but it won't like randomly kill something. So yeah, if it happens that your process crash, everything goes down with it. But the Ruby VM takes care of like scheduling the fibers and the threads.
Okay, thank you.
Hi, I'm Luptak from g2.com. My question is, we all know that DB connection pool is something that we use and it's not thread safe. And I want to know, that is the reason why Puma spins take up one connection per thread for every request. I want to know how things change with respect to this with Falcon server.
Okay, excellent question. So the Rails 7.1, which is not yet released, has a setting to make active record connection pools fiber aware. So you can just set that and run it with Falcon. So you can run it even without that. The only thing is you will not get as much performance because it's still going to run a thread pool. But if you want to have your DB also run async, you can set that and it will become fiber aware.
Hi. Hi, Siddharth. Perhaps this has already been answered, but I can't just start using async gem in my Puma server and expect to see anything good happen, right?
You can use async gem without using Falcon, but it makes sense only if you have like multiple requests in one request response cycle. But the thread will still block until all the requests come in. So
Right.
it's not going to be of much benefit.
Understood. Thanks.
Hello. Yes. So I have a question related to the connection pool earlier. So a database had a limited connection, right? If we use Falcon with our like connection pool, then how do we ensure that we don't like go over the limit of database in terms of the number of connection?
Yeah. So I haven't actually load tested that. That could be a possibility that you have too many requests and every request is opening a connection and your DB becomes overloaded. So you might want to keep that as a thread pool instead of fiber aware if you can't limit the concurrency. So that is a possibility that like Postgres, for example, each connection is expensive. You have like limited number of connections available. So if you open up a connection for every request, your DB might go down. So that's something you will have to test it out on your app. But the advantage is that there are a lot of serverless DBs now, like Neon, for example, which is meant to like integrate with JavaScript and all that, where they open up a connection for every request and they manage it. So if you're using something like that, then go ahead and do it. But if you're using like Postgres, you may still want to use a thread pool.
Thank you.
Hello.
Yeah, hi.
So my question is, like, we are using Postgres and we have like a lot of query happening in the controller. So if we use the async gem, like, will we be able to eager load the responses as well? Or like if we are building a report, will we be able to, build it faster using async?
Okay, so you will, for the full benefit, you will have to use Falcon. The reason is, when you're using Puma, even if you use async gem, you will have to wait for the result of that, right? And the thread will still block. The thread is not available for any other request. Whereas when you use Falcon, that fiber is cheap, okay? And the fiber will sleep until the requests come back. And other requests can continue processing. So that is the biggest difference, that you have a request per fiber, and fibers are very cheap to create. So even if your fiber is sleeping, waiting for some slow DB request or slow network, it doesn't really matter. The other requests can come in. So for the full benefit, you'll have to use Falcon.
And on the lines of, as a fellow mentioned, like if we have a lot of connections, we might run into, the connection pool limit or something like that. So is it, like, I feel that there is a possibility that while we are coding using asm, we just do a n+1 query. We just call the async inside a loop, and we do the n+1 query concurrently. So will it still work, or will it be a CPU intensive task which will hamper the entire application or might hamper the DB connection requests?
So n+1 queries, it can be CPU intensive depending upon if you have a lot of rendering of views or anything like that. But for the loading of the database, as I said, you can keep your active record with a threaded connection pool, and that will limit the number of connections. If you're worried about the number of connections, keep it as a thread pool.
Even if we do n+1 query we're using async gem, it will still
go through that pool.
Okay.
Yeah.
Thank you.
I think we have time for only, how many people still have questions? I like the way he's structured his talk, because he kept out almost like 10 minutes for questions, and we're still running out of time. So I'll take last 2 questions, okay?
Hey, based on the original premise, have you considered using Lambda or Google Cloud Functions as an alternative to Sidekiq for running background jobs? So you kind of reduce the maintenance overhead.
But I'll have to run the entire thing on Lambda, right?
It would depend. If you have like specific jobs, then you can just push those jobs into Lambda, and then you basically run it from Lambda, so you don't really need to run like a job pod or something for that, for those specific jobs.
Yeah, but I'm not trying to say don't use Sidekiq, right? It's like you're waiting for an API request, and you have a Rails app. And in a Rails app, your users are authenticated. You will have your environment variables, everything to make an external API request. If you're going to put that in a Lambda, you can. But then you're running Rails in Lambda, which is not what it is required, right?
The debate is taken offline. Okay. Okay, I would say that would be slightly, you don't want to debate between Lambda and Falcon. So please, good over lunch discussions. I'll take one last question here, please.
Good morning, and thank you. Very, very interesting.
Thank you.
Practical application. I think the seed was planted yesterday with the word async being even mentioned, and I think a lot of people have had the opportunity to develop. My question, and I guess it's just an invitation to think about the future of being a Ruby developer as well. So from a CTO's perspective, this is like immediately attractive, because now I can talk to my clients and say, hey, you don't need on Heroku to have 3 kind of instances running, one specifically dedicated to your worker. You can be running it all on one instance, right? That's the general advantage, right? You're going to save cost in terms of how much server instance you're provisioning.
Right.
But from, I guess, just reading the room as well, if we're thinking about the future of being a Ruby developer, part of the blurring of the lines now, say for example, with the mindset of a Node.js developer versus now what is a Ruby developer, I'm just interested in what are the type of things we should be thinking about now in terms of how we structure our approach to coding with the general, async is fantastic. You just put the word async and you wrap everything around it, but that is a very, on the surface, seems like a very, almost too easy solution. So just a general thing in terms of what you would suggest in terms of how people can proceed from here.
Too big.
So, yeah, best practices, in short.
Yeah. I'll just pick on something that you said. It seems too easy. And it is. And that's why I said it's an incredible piece of engineering. Because the magic happens in the fiber scheduler. So yesterday's talk, you saw that like when a fiber runs, it has to yield for the other fiber to run. So what the fiber scheduler in Ruby 3.0 does is, it does not come with a default fiber scheduler. Okay, async provides a fiber scheduler. You can provide your own fiber scheduler if you want, but async works great. What it does is, when the Ruby VM encounters a blocking I/O, it looks to see if there's a fiber scheduler defined, and then it, asks the fiber scheduler, okay, now it's you deal with it. So what the async gem does is, okay, it sees blocking I/O, it gets that request, it says, okay, now you sleep, I'll let the other fibers run. And it also has an event loop which like makes a, wakes up the fiber when the request comes back. So it is easy because they have made it easy. As for the future, this thing, I just think you have to, you can think like how, like a Node.js developer does. Like, they don't worry about making external requests. Like CPU intensive tasks, yeah, the wisdom is don't block the event loop. Like, you can approach it in the same way. So I think that's like very, very powerful. That's all
I think, thank you so much, Manu.
Thank you.